Okay, so today we are going to be finding tangents, and more specifically, slopes of tangents, okay? Because the whole difference, I guess, between pre-calculus and calculus is that in pre-calculus you would not find a slope of a curve at a specific point, and calculus, that's what it's all about, okay? And as you look through this entire unit, we're just going to be doing stuff that's based on slope, okay? So I don't know if you remember from grade 11 when we were doing maximum and minimum problems, but when we were doing maximum and we would do the graph, right? And the very top of the graph would be the maximum, right? And then we would go left, right, and find the max, right? In our calculators, remember doing that? Well, what's the slope at the max? 0. So if we know the slope is 0, then we can actually find that faster mathematically. Maybe not as fast that you can do graphing, but faster mathematically, since you know that the slope is 0 at max. Now, I'm going to show you two different ways to find the slope of a tangent. And one is more preferable by students in high school, and the other one is more preferable by math professors at university. So I'm going to show you both, and you can decide which you would use for a test. But just I want you to be familiar with, obviously, the university professor preferred way, so when you get there next year, you've seen it. And maybe, because you'll all find if I give a test, probably 90% of you would like to do it the easier. Well, it's not really easier. It's just maybe more student-friendly. 90% will do it that way, and about 10% will do it the university way. Now you can see the obvious disadvantage at this point, but you can see the obvious advantage later next year when you're doing these and you've had practice with it doing the university way. So I'm going to just work through the left, and we'll work down the left column, and then we will do the right after, okay? So I'm just going to call this like method 1, and this one method B. No, just kidding. You guys panic a little, though. It's kind of funny. Now, I want to find the slope at point A, comma, what is that? This would be A, comma, no. Instead of, and not even close, any of you, okay? It wouldn't be X. X would be bad to put in the Y spot. Okay, first of all, let's start there. We would put Y, but we could be more specific because it's always the function. So it would be f of A. Okay? Now, if we're first going to start with, let's say we're going to find the slope of this. Now you can see right now, that doesn't look like it's going to be the slope at point A, but it's right now just an approximation. So we're going to call this x, comma, f of x. So this is going to be point X. Okay? So this is pretty small here. I'm just going to make this a bit bigger. Now, do you see that as I start moving this point right here, let's call that point Q, and we'll call this point, I'll put the Q here, and I'll put this point P, okay? So as point Q moves closer and closer to point P, do you see And I can actually, but as point Q moves closer and closer, you're going to see that we will get closer and closer to the actual slope there. Okay? So this is where we're going to talk about limits, because we're going to try and move Q, point Q, as close to point P as possible. Now, if they were right, like, you know, if you could take a microscope and get really, really, really close to it, there would still be 2 points, okay? And you'd get really close to the actual slope, okay? Now, so what we want to do to get the best approximation is we want to start moving X. We want to start moving this dotted line, or this X, closer and closer to here. So basically we're kind of at this point, right? That if X got all the way over there. Now, how do we find the slope at this point right now? We will go, okay, so the way it is right there, we're going to go delta y over delta x, which is y2 minus y1 over x2 minus x1. And I think this is why this is the student preferred way, because they're like, yeah, I know that formula, I've been using it forever. And then all I'm going to do is I'm going to take the y's, which is f of x minus f of a, and I'm going to subtract x minus a. Now, what we want is we want to get Q moving closer to P. Now, when that happens, X gets closer and closer to A. So delta X, okay, just so you know, this is delta X, change in X, or the difference between the two. It's going to get closer and closer to 0. Therefore, MPQ will get closer and closer to the slope at that point. Okay, as Q gets closer and closer, you will see that it will become the slope at that point. So what we're going to do is we're going to do a limit. We're going to do a limit of delta y over delta x as the difference between here and here becomes nothing. Okay? Because when the difference between these two becomes nothing, now we're not going to get right to nothing, we're going to get so close to it, we're going to get to its limit. But that's going to be the most accurate slope. If P and Q were micrometers beside each other, we're going to get the closest slope. Okay? So the formula for this will be f of x minus f of a all over x minus a. Oops, I forgot to write limit again. Equals a limit as x approaches 0. So that's just your slope formula, and that's what we're trying to find, slope. So that makes a lot of sense, right? Now, oh, I guess I could have rewrote it. Let's just rewrite it again. So the limit as x approaches 0, f of x minus f of a over x minus a. Okay? So this is most preferred in high school because it's a slope formula. Easy. I got, you know, my f of x, that's my y's, divided by x minus a, that's my, and then I could say, hey, as a gets closer and closer, or x, sorry, gets closer and closer to 0, then my slope gets more and more closer to the point I'm looking for. Okay? Now here, method 2 is doing the same thing. It just does the naming a bit different. Now, we're still going to call this point P, And that's still a f of a. Okay, so far so good. Looks just like the other one. Now, instead down here, instead of calling this x, we're going to say this is a. We're going to say this distance over here is distance plus a. Makes kind of sense, right? This was 5. This would be like 5 plus 3, the distance that it moved more. But we don't use distance, we use the letter h. So if that's a, that's going to be a plus h. Again, it makes sense, but it's not as nice as x that you've always used. So this point here will be q. And obviously now, by looking all the way down, the x value will be a plus h. And the y value will be f of a plus h. And you may remember putting a plus h into your test question that I had you do about a week ago. Okay? And actually you came up with trying to use this formula. Now, so I always call this is my x1, y1, and this is my x2, y2. Now, I'm still going to use the slope formula, but I'm going to put all of these values in. Okay, so delta y is y2 minus y1 over x2 minus x1. So y2 is f of x plus h minus a minus f of a all over. Now, I'm only going to do this one time, and then you're going to see it's a waste of time if we did it all every time. This is going to be a plus h minus a, which equals just h. Okay, so the real formula is f of a plus h minus f of a all over h. Now, what does h stand for again? The distance between them. What do we want that distance between them to become 0? Okay? So this one's nice because it just says, let's make the difference as close to 0 as possible. So as q gets closer to p, delta x will approach 0. Therefore, h is approaching 0. And then that m, or slope of PQ, becomes the slope of the tangent. Okay, so the formula is, as the limit, so mt, as the limit h approaches 0, is f of x plus h minus f of x all over h. So this would be, oops, I don't know why I keep doing that. Yeah, you can use a or x, doesn't matter, but we'll keep it. Okay, so this is preferred in university. In fact, you probably will not see the other form, and textbooks do not really use the other form either. Question? Yep. Say that again? No. No. No, you'll see why. You can't split up a function like that. Okay, so what we're going to do is we're going to do, we'll just do 2 questions here, and then the next page is actually the same question, and we're going to do them the same question 2 different ways. So actually, that makes more sense. Let's do this one, and we'll do it both ways. So we'll just draw a line right down the middle, and we'll do it both ways so you can compare the two. Okay. So we're going to cross this out and use both methods to find the slope of the tangent. Answer in general form. Okay, now here's the kind of way that I always get this stuff sorted out. Now we have a point, or sorry, we have a line xy equals -6. I mean, we can just change this to y equals -6 over x, right? That's how we would graph a line. So we've got this curve, or this line, -6 over, it's not a line, actually, it would be a curve, -6 over x. And it wants us to find the equation of the tangent line. Okay, now to find any equation, you need the slope. So we've got to do that first. And it's going to be at this point here, because the slope's always changing. So if they don't give you a specific point, you can't find the tangent, or the slope of the tangent at that point. And we'll call this A and f of A. Okay, so let's do it the high school way first. So we're doing the m of t. So it's the limit as x approaches A of f of x minus f of A all over x minus A. Okay. So, as limit x approaches A. Oh, sorry, as we can start getting specific now with our formula. Since the point is 2, -3, we want to approach 2 get as close to 2 as we possibly can. So it's f of x minus f of 2 over x minus 2. Okay, so my A I got right from my, and it makes sense that we want to get his number. We can't put 2 in here, but we want to get as close to it as possible. Okay? Because you can't find the slope using only one point. And if we use 2 twice, you've only used 1 point. So we want to kind of use 1.9999999. Okay? Now, when we get to this stage, we want to actually, well, what is f of x? We can very specifically say that is going to equal, because it's the same thing as f of x, right? That is going to equal, so this isn't the nicest one to first learn with because of those fractions. So mt equals the limit as x approaches 2 of -6 over x minus, I'm going to just put this in here, over 2 all over x minus 2. Okay, everyone get that step? So now we actually want to try and get that top together. Now, I actually made this into -3, but so I'm going to do that step because it is easier finding common denominator. So this will be, because you'll always get an answer. I just knew if I would put -3 there, I'd lose some of you. So that's -6 over x plus 3 all over x minus 2. Okay. Now, when you start to do these, you're just going to put the 2 right into it. and get this, right? But I wanted to show you I put 2 into f of x. Yeah, you put point a in there, right? Because remember, I labeled this a comma f of a, so I put a into, so what's f of a? Put it right into there, and you will get. Yes, yeah, you can always do that too. One thing I've found that a lot of questions, when x equals 2 is all they'll tell you. Okay, but you're right, you could just put in the point, or you can solve it. Okay? So there are questions where they just say when x equals 2, and then you just have to, you can put it into here at this stage and just put it in, or you can put it in here. Okay? So we do want to add those two up top together, so I'm going to do this. Okay? Just find a common denominator. So that would be limit as x approaches 2 of 3x minus 6 over x minus 2. I just put the positive one first. I could have negative 6 plus 3x if I wanted. Okay. So the limit of x goes to 2. Now, remember what our goal always is, right? We still can't put 2 into this. We need to cancel that x minus 2 in the bottom. And this works out to be nice because this is 3 bracket x minus 2 over x minus 2. Now remember, division is the same thing as multiplication by the reciprocal, right? So limit x goes to 2 is the same thing as 3x minus 2 over x times 1 over x minus 2. Okay, these will cancel. And you'll get the limit as x approaches 2 over 3 over x. Now at this point, I can just go and put in the 2. So if I substitute, I would just go equals 3 over 2. You don't have to write limit anymore. And that's your answer. So then you get y plus 3 equals 3 over 2 x minus 2. Y minus y1 equals 3. Slope times x minus x1. Okay, so this is y plus 3 equals 3 over 2x minus 3. Multiply everybody by 2. I get 2y plus 6 equals 3x minus 6. And let's get everything on the right. That would be 3x minus 2y minus 12 is the equation of that tangent. Okay, so that's doing it using f of x minus f of a. Why don't we do now the limit as h approaches 0, f of x plus, or sorry, a plus h minus f of a all over h. So we know that a is 2. So we're going to put 2 wherever we see an a. So limit, I guess I should go mt equals slope of the tangent equals the limit as h goes to 0, f of 2 plus h minus f of 2 all over h. Okay, so what we're going to do now is we're going to put 2 plus h into the function and 2 into the function. Okay, so the limit as h approaches 0, that's negative 6 over 2 plus h minus, now if you put 2 into the function, you will get negative 3. And they've also given us f of a, or f of 2, and that's all divided by h. Okay, so the reason why this one isn't a very nice example is because we always have to find a common denominator at the top. H goes to 0, so negative 6 over 2 plus h minus, or plus at this point, 3 times 2 plus h over 2 plus h all over h. Okay, so now we have limit as h approaches 0, negative 6 plus 6 plus h all over 2 plus h. Or sorry, over 2 plus all over h. Yes, sorry, 3h. Okay, these are going to cancel. We will have the limit as h approaches 0 of 3h over 2 plus h all over h. Now, and you'll when you start doing enough of these, you'll see that the top and the bottom will cancel. But remember, when you divide, it's the same thing as multiplying by the reciprocal. So that's 3h over 2 plus h times 1 over h. The h's will cancel, leaving me with 3 over 2 plus h. Now I'm ready to substitute in my 0. 3 over 2 plus 0 equals 3 over 2. Okay, so got the same slope, and then you can just do this one more time, obviously, because finding the line is the same after you find the slope, right? So the reason why I wanted to give you this example of showing you both at the same time, I think, is for you to see the differences, the similarities, maybe which one you prefer more. You can get away with using one at all times, okay? So if you're going to pick both to keep doing back and forth, you might find that you might make more mistakes than if you just stuck with one way. Okay, so these ones are nice too. They give me both points. Now, what should I always call my point? A and f of a. Okay, so you get kind of good at that. It's going to be a, f of a, no matter what. Even the next one, we do a, f of a. Okay, so this one says find the equation of the tangent to this parabola x squared minus 2x at the point, negative 315. Okay? So, let's do it the slope. So, we're going to go as limit as x approaches a of f of x minus f of a all over x minus a. So we're going to get x as close and close as we can to that bottom value. So the slope would be the closest. Now, we want to get as close as we can to negative 3. So the limit as x approaches negative 3 is f of x minus f of negative 3 all over x minus negative 3. And then maybe you're going to start skipping this step and just put f of x minus 15. Okay, so as long as you're keeping this stuff straight, because that's what I would do, I would just go f of x minus 15 over x plus 3. Okay, so maybe this stage here makes the most sense, right? Take your f of x minus f of a and x minus a. Oops, I have no idea. Negative 3 there. Okay, so we want to get as close to negative 3 as possible. Right now we can't, because if I put negative 3 in there, I will get undefined. Okay, so now I'm actually going to put in the function limit x approaches negative 3, f of x squared minus 2, or sorry, I'm just going to put the function in, x squared minus 2x minus 15 all over x plus 3. So I put in f of x. I could have put in f of 15 and then figured, or sorry, f of negative 3, and I would have got the answer 15. And some of these, they will not give you the y value, so you will have to figure it out. You can put it in either at this step or find it at first. Okay. So now we can factor the top. Which is negative 5 and 3. So x minus 5, x plus 3, all over x plus 3. Okay, you can cross those out now. So I am now finding the limit as x approaches negative 3 of x minus 5. So now I can just put it in, negative 3 minus 5 equals negative 8. So that's the slope of the tangent. Okay, and y minus y1 equals mx minus x1. Y minus 15 equals negative 8 times x minus negative 3 is plus 3. Y minus 15 equals negative 8x minus 24. We'll get it all on the left, or on the right, sorry. Y equals, oh no, I should have put it on the other side. Anyway, I'll change it after. 8x minus 1y minus 9. And you shouldn't have a negative value in front of the x. So we're going to multiply everybody by negative 1, so 0 would equal 8x plus y plus 9. That is the equation of the tangent line to that curve at that point, negative 350. Okay. Let's do it one more time using the other way. So mt equals f of a plus h, oops, for the right limit. The limit as h approaches 0, f of a plus h minus f of a all over h. Okay. So limit as h approaches 0, we're going to go f of 8 plus h minus f of a, 8, all over h. Okay, we do already know the equation. So limit h approaches 0. We are going to put 8 plus h into the equation. So that is going to be the square root of 3 times 8 plus h plus 12 minus. And you could put 8 into that, but they already gave us the y value, so we can just put 6. But if you put 8 in there, you do get the square root of 36, which is 6 all over h. Okay, this one, you should at this point go, oh, this is going to be fun getting that h to cancel. You're going to have to be multiplying by a conjugate. So this is the square root of 24 plus 3h plus 12 minus 6 all over h. I know this is a lot of lines that we're writing over and over again just for one little change, but if I skip the steps when I do the notes, I just have a bunch of people confused. So now I'm actually going to get 24 plus 12 together, and that is the square root of 36 plus 3h minus 6 all over h. And then at this point, you're going to go, I cannot go anywhere except for trying to get rid of that radical up top. Because I got to cancel h. I can't even get rid of h. Therefore, if I put in 0, it's still undefined, and I have accomplished nothing at this point. So I'm going to multiply that by root 36 plus 3h plus 6 over root 36 plus 3h plus 6. Now these aren't as bad as they seem because we do not have to multiply the h in on the bottom. If you do enough of these, you're going to go, the whole point of doing this is to get h to cancel. So why put it all in? Then I'd have to take it all out and then cancel it, right? So we get rid of the radical signs up top. So limit as h approaches 0, that'll be 36 plus 3h, because that's going away. And then negative 6 times positive 6 is minus 36 all over h times 36 plus 3h plus 6. Okay, these will cancel. Now since I have 3h all by itself, 3 is multiplying to h. Those are factors. We can cross out this h with this h. Now you couldn't do that if you had numbers with it, but we have 3h, so you can cancel the h's now. What I mean is, if there was, 24 or 3h minus 24, okay, I can't go cancel the h's because I can't factor out an h. So this would be the limit as h approaches 0 of 3 over root 36 plus 3h plus 6. So at this point, 0 is now going to be allowed in there. And since I'm just going to sub it in, that'll be 3 over 36 plus 3 times 0 plus 6. This equals 3 over the square root of 36 is 6, plus the other 6 that was there, equals 3/12, which equals 1/4. So m of the tangent is 1/4. So y minus y1 equals mx minus x1, y minus 6 equals 1/4 x minus 8. Okay, you can multiply everybody by 4 now if you want. It should give you 4y minus 24 equals x minus 8. Okay, and let's get it all on the right. 0 equals x minus 4y and the negative 24. That becomes positive 24 plus 16. Okay. And then later in the course, I'll show you that you do not have to know how to do this to find slope, but you need to know how to do limits. Actually, even when you get right to university, you spend a bunch of time on limits too. Okay, so, oops. You guys have the homework, don't you? Yeah. Yeah, we'll try. Because I thought I did it, I might have just said it wrong.